Hi everyone, I want to perform my project using a graph databases in natural science. There are a lot of natural science topics where you can use graph databases, for example, ecological models or biomedical and chemical researches. For example, disease pathways, a model for gene interactions, and protein structure model. In this project, I will focus on drug modeling, how to add it into Neptune database using Gremlin API. This is the molecule I used over here, and you can look for it using Google or Wikipedia. Neptune database is fast and reliable. Also, it has the properties of atomicity, consistency, isolation, and durability. It is totally cloud-based technology, though you can use the same Gremlin language on your own machine. And just download Tinker Proper Gremlin server. Also, you will need some Python installations. Neptune database supports several query languages, and one of them is Cypher, which you already know. Also, Neptune database has a machine learning option. For example, if you have added a lot of molecules, you can predict some possible graphs using this machine learning. I will not cover it in this presentation. Gremlin API is totally schema-free and user-friendly language. It has a lot of aggregation function and integrated with Python. First, what you need to do is to create a database on Neptune Cloud. You just need to go over here, databases and Neptune, and then you will see the option to create database. When you have created it, I used everything by default and it works. You need to fix this endpoint and port number. And while you created it, you click over here on notebooks and can create some notebook files using Python language. Here is I downloaded a file which contains crystallographic information about this drug. It is the formula of this drug, and the file has a structure. The keyword loop defines the start of a loop. Like here, you see headers, and below you see the data. And then we have one more loop, which is for connection of these nodes. So I just read this file and then define the blocks. And you see here I can read the headers, and then I can create a data frame for first for nodes and then for edges. It takes a while, and while we got these data frames, we can move on. I imported a Gremlin Python module, and what we need here is to specify this connection. Here I copy this endpoint and put it over here. The code is about the same for localhost. I will provide it uh, in project files. If we need to delete something, I don't want to delete anything, it is this line of code. Then if connection is good, I will get 0 over here, so I don't have any nodes or any edges. Then we add nodes using function graph, add vertices, and specify what type of data you want to use for label, and then for properties like ID and something else. And finally, you need to specify next over here. It is necessary when you use Gremlin using Python. And here I am getting, and we can look over the list of these nodes to check what we have added. Then we move on and see here atom 1 and atom 2 and their connection, single or double. And here how we add this connection. First we need to get these nodes, like here atom has ID and we specify it over here, and then add edge, edge label, and then properties. We can add as many properties as we want, and then we specify the second node 2, and over here you see I used double underscore instead of a G. It is necessary when we specifying incoming edge. And here we can print the list of those connections. For visualization, I used Graph Notebook. The only thing I specified over here is again endpoint and port. And if you need to change, for example, the shape, you can write something else over here. But first you need to write here double percent and write what you want to get. And then we can get an output. It is a simple graph. Here you see everything is labeled, like every node is labeled. It is nitrogen, carbon, and hydrogen. And you don't see here any properties, but we can get them also. You can move the nodes to get the structure. That is easier for you to look. For example, like this, and it's very similar with what we had in the beginning. Here I'm specifying node labels and edge labels, and to display them I write over here D. Also I show out edge and in vertex. So you will see the graph with arrows from one node to the other node and with the properties that you want to see. For example, for this node, I see ID and residue number, and for also I can see the properties for edge. Then we will move on and we'll show only two types of atoms. It is carbon and nitrogen. Here we see the chain that is not looped. Then we can select only one type of node and one type of connection for this node. It is one only. If we use aggregation function, we will get one over here, and we can look how it is shown on graph. It is one node, this node, and it is connected with C36. We can show all edges and connected atoms for this node N7. So it is over here, one double connection and one single connection. Also, you can use this Gremlin language on your local machine, and then you need to install Gremlin Python, Graph Notebook, Magic Command, and IPython Gremlin. And also you need to load a couple extensions, Graph Notebook, Magics, and Gremlin extension. Then you need to start Gremlin server. It can be started using this command, Gremlin, and you see this server is already running in my case. Then you specify over here localhost, Gremlin port number, and Gremlin. The port number is, as I see, the same every time. And check the connection. Here we got 0 and add vertices. And now we are getting 167 nodes, and you see those nodes. ID that is created automatically in Neptune database, and on this local host is very different. Here it is much simpler, and we can see the same. And when we specify graph notebook config, we use here localhost, and we can get some graphs that are not so perfect like you saw on Neptune database on server. It is a powerful tool. I really enjoyed working with Neptune database. It has a variety of opportunities to get the graph. Maybe visualization functions are not so straightforward as I wanted, but Neptune database offers some other options for visualization. And you can look how many tools offered for it by documentation. And what I liked most of all is that Neptune database provides an opportunity to use machine learning. Thank you. for your attention.